Welcome to another edition of Excel VBA Fun with Games. This game is Connect4. This was inspired by Pete's spreadsheets. I like the way that he used the conditional formatting to set the gameplay area up. This version of Connect4, it uses conditional formatting for the gameplay area. It also uses conditional formatting for the column indicators. It also uses labels, activeX control labels. These are used for the mouse indicator, which allow the user to make their next play and add a counter to a column. It also uses user-defined functions. These are functions that you create in VBA and you can use on your spreadsheet in a similar way to the inbuilt Excel functions. It's a great way to enhance your spreadsheets. Without further ado, let's go on and have a look at how the interface has been built and the coding behind the interface. The Connect4 game only has one worksheet that's named Connect4 on the tab. The menus have been hidden and we need to view the grid lines, headings and formula bar. There's some groupings in here, so if we expand the groupings, the gameplay area has been given a named range, Nboard. Its background has been set to blue and it also has conditional formatting in here for the counters. So if we pop over to conditional formatting, we manage rules, we can see that it's an icon set and it applies to that range. Edit our rule, you can see icon set, show icon only, and we can select the icons that we wish to use. So these have been selected from the drop downs. We make the value type a number. We say that when the value is equal to 2 or greater, then we're going to show red. If it's equal to 1 or greater, then we're going to show yellow. If it's less than 1, then we'll show white. So this shows us a clear space, player 1, player 2. So that's the conditional formatting for the game area. Now if we have a look at the counter indicators at the top of the game area, these are based on conditional formatting also. You go to conditional formatting, we can see once again it's an icon set. If we edit the icon set, we can see where we've collected these. So these have all been collected from the icon set, and just as the game area is their number type, player 2 is a value above 2 or above, player 1 is value 1 or above, and then we say that if it's less than 1, then we're going to show an X. An X means for us that that column can no longer be played. We cancel out of there. The only other conditional formatting we have on the screen is for the player indicator, and that is player 1 is yellow, player 2 is red. And we can see here if we put a 2 in there, it goes red, and if we put a 1 in there, it shows yellow. And this is updated by the macro. What we need is a way for the users to add a counter to the game area. So what we use is we use a label, an activeX control label. If you notice that when we move the mouse over the top of a column, the mouse pointer changes. And this is done through the activeX label control. And if we select that column, we add a counter and the counter moves down and updates the game. After the counter's moved down and updated the game, the player then changes to the next player. So in this case, player 2. If we do the same again, we can see that it changes against player 1 after player 2's scope has been taken. And this works all the way along here, and this column here we can see an X above there. We click on this, nothing happens. The player doesn't change, nothing gets added. It's as if you have not taken your go. But what we have done by clicking again is we've removed the activeX control. So if I now try and click it again, I won't be able to click it. How we add the activeX control to developer, quick design mode, insert, and what we do is we choose an activeX control label. So if I just select one, and if I just plonk it in here, that's my label there. I'll call this LBL underscore 10. What I need to do is I need to go to its properties. If I select categorize, its back color I leave as Windows background. Back style I change to transparent. Caption we remove, we don't want any values inside the label. Mouse pointer, we set the mouse pointer to custom. Mouse icon, we're going to use a custom icon, and I have one already prepared. Open. And the other thing to recognize about this is that we have a left position, and that's the left pixel position, and we have a top pixel position, and both of those give us the coordinates of where the activeX control is. So if I close this down, and we can see here that the activeX control, the top and left, is that area just here, and that area just there, we use that to locate the activeX control to a cell. In this case, the cell would be K2. If I take it off design mode, we can see that the changes we've made, as such, the mouse pointer changes when we move over it. The other thing that we do is we have a formula in here which tells us what icon to show. It's a simple if statement. If H7, which is the first row of the counters in the game area, does not equal 0, then the value in this cell equals 0. And as we learnt from conditional formatting, it's a 0 value, it will show an X. Otherwise, it will show N player. An N player is the current player of the game. Move over to the named range N player, we can see that N player is here. So that's how we change the top indicators for the columns in the gameplay area. The next thing to do is calculate whether we have 4 counters in a row, and how we do this is with the user defined formula. If I click on rows, we have an OR statement. I click FX, and we can see that within each element of the OR statement we have an FTN RNG formula, and that formula is user defined. This was created in VBA. So an example of that formula would be equals FTN range. What we can do is we can select our function arguments. So range, if I take that range is going to be this row, the int value, we'll call it player 2, and the match is we're going to match 4 in a row. And our formula at the moment returns 0. We'll say OK to that, and we can see that we only have 3 counters along there, and our current player is 1. So if I change that to player 2, if we can see our value here is 0 still, I'll change this to 2, and we can see that we're still at 0. Even though we have 4 counters in that row, we're still at 0. They're not 4 continuous counters. What I'll next do is I'll add 2 in here, and we can see that our count is 4. And what we're doing here is taking the first 4 counters, and then the function stops. It says we have what we need, and it returns 4. For all rows, if I enter here, we can see we have each row here within the OR statement. So if any row produces true, then the answer for rows will be true. Likewise with columns, and we can see that we have 1, 2, 3, 4, 5, 6, 7 columns, and it works as exactly the same formula, works the same way. Diagonal is slightly different. We'll look at our formula, and we can see for diagonal that we have FTN range, but our ranges are separate ranges within brackets separated by commas, and then we get our player and how many consecutive counters we want. So diagonals work slightly differently. To enter a diagonal, select our FX function. Now Within here I've put the brackets, and now what I'm going to do is I'm going to select each cell individually, pressing the Control key. So select each cell, press Control key, and I'm going to make this N player, and we want 4 counters, consecutive counters, and the result is 0 so far. So that's the result of 0 so far. That's the game. Pressing New Game clears the screen, and we're ready to play. The other thing that we do is we just group our formulas, so we just so that we hide them from the gameplay area. Now the code is separated out into 2 areas. We have our Connect4 game sheet. We have our code on there, and this is where we get our feedback for the activeX controls. And then we have a normal module, and we've called it MDL Connect4. When a player selects the New Game button, New Game is run. And what we do is we select the sheet Game. Now Game is the code name for the worksheet Game, and we've defined that. We have a look at the properties window for Game. We can see that the name brackets Game, that's the code name for the worksheet. If we go down to here, we can see name again, and this is what the user sees on the worksheet tab. Now the user can change this Connect4 name to anything they wish, and that would change the name of that worksheet. But because we're looking at name, the code name, it doesn't matter what the user changes the tab name to. So we refer to Game, and we're putting this within a with statement, which is a shortcut for game.range, game.hide show levels. So a new game. Next we reset the game board, the game area, to value 0. So every cell is changed to value 0. Range N player, that's changed to 1. So we're saying that player 1 is ready to go. And the next thing we do is hide show labels with a parameter true. So we go over to game, hide show labels. We can see hide show labels as a comment here. Be hide, which is the parameter. False means that we're hiding the labels. So if we send a true, we're showing the labels. So what we do here is we loop through each L in me shapes, and me is a shortcut for this worksheet. And because this code resides within the game worksheet, we look at each shape in me worksheet shapes, and then we test the name. And if the name begins with LBL underscore, then we're going to make it whatever the call is. We're going to either make it visible or not visible. In the call for new game, we make all the shapes visible, all the activeX labels visible. When a player makes a selection, they hover the mouse over an activeX control above a column, and that triggers a piece of code for the activeX control. And we have an activeX control above each column. This is for the first column, and this is LBL underscore 1. And when we click that activeX control, we run this code. Now our first line of code is get the range from the label pixel position. So what we mean by this is we know the pixel position left and top from the label, and what we want to know is which cell that resides in. So what we do is we've created a function and we apply the answer to ANS, which is shortcut for answer. We pass to it the left coordinate and the top coordinate. So we have a look at FTN range from pixels, which is in MDL Connect4. So this I picked up from Mr. Excel. It works perfectly well as it was there. There was only a slight change. Here we loop through each column. We look at its left pixel position. We compare that with the left label position that we gave it. So DBL left is the label position we gave it from our activeX control. We keep doing that until it finds a match. And when it finds a match, it records which column that is, and then we exit the loop. We do the same for row. We step through each row and we compare the row's top position to the label position that we've given it, DBL top. Once the pixel position for the cell is greater than the activeX control top position, we record the row. So we've now collected the column and the row of the cell. We apply row and column to cells to give us a range, and this function returns a range. So we go back to our code. So we set answer, which is a range, as we can see here. Next thing we do is we test whether that column is viable or not. That means, is it full up with counters or not? So we call another function, and this function is function play column, and we give it the range and we give it the label that was calling it. FTM play column function. This is a Boolean function, so it returns either true or false, and its arguments are range and the label as a variant. So first off, we set the function as a default to false. Then we test to see whether the range value is 0 or not, and that range value is the icon on top of the column, and there's an if statement that gives us 0, 1 or 2. If the result is 0, then we make the label not visible. That means that the user can no longer select it. We set the function to return true. This tests whether a counter can be added to the column or not. This test, FTN play column, will either return true or false. If it returns true, then we'll exit this sub, and that means that we'll no longer be able to add a counter, and we won't switch to the next player. In effect, we're ignoring this action and we're disabling the column. If it returns false, we move on to the next piece of code. And the next piece of code is adding a counter to the column, and we call add counter. We have a range that we pass to it, and we pass the player. This will be either player 1 or player 2. Add counter subroutine, as we saw, takes in a range and will take in the player as an integer. And our notes, add a new counter to the game and move into position, includes a wait to give movement to the counter. What we do is we set R and C, which represent row and column. Column we get from the parameter from range. Row we set manually to 7, and that's because of where we place the game area within the worksheet. The next thing we do is run a loop. We keep running in a loop until the cell does not equal 0. Our gameplay area is set up with zeros, and that's what makes them look clear, as if there's no counter there. If the cell is 0, we're going to clear the previous cell to the cell we're on by adding 0 to it. The cell that we're on, we're going to give it the player number, so either 1 or 2, and the conditional formatting will show a counter. Next we increment the rows to +1 row, so that's moving down the board, and then we add a wait, and we're going to wait 1 second before this loop reiterates. So in effect, we start off with a counter at the top of the game area in a column, and every second it moves down to the next row until it can't move on anymore. That is, that there's a counter in its way or it's at the bottom of the game. To quickly look at the bottom of the game, we have a look in the shadow here, we can see end. This end helps this formula know when it's reached the bottom of the gameplay. So how that works is we select a column, we click, and the counter moves every second down until it reaches the end. So when we add another counter and it moves down through the loop, it'll encounter 1 and it will say, okay, I can't go any further, I'll stop there. How it moves is, puts one in there, and then it looks at the next cell, and if the next cell is 0, then it says, okay, I'll make me 0, and I'll make me the next cell 1. And that's how it moves down. And this is how add counter works. The next thing to do is test whether we've won the game or not, what actions we need to perform next with the game, and we call game control. Game control detects game over, draw, or continuous playing. So we have an if statement that does this. So we say me, which is the game worksheet, range end draw. So if end draw is true, then we're going to hide the labels, the activeX controls, so that the player cannot play anymore. And then we're going to show a message box. The game is a draw, play again. We have an else if here, and we say that if me.range game over, end game over, we're going to hide the labels, and we're going to show a message box, player 1 or 2 has won. Else, this means that the game's still in play, and we're going to change the user. This means that we've added a token successfully, the game is still in play, so the next player needs to go next. The named ranges that we're testing for, end draw, which is draw, this cell here, which is a sum of these cells, and we say sum these cells, and if they equal to 0, then it's true. If they do not equal to 0, then it's false. We can test that. What we can do is we can put a value in here, and we can see all these have returned a result that the column is full up, and we can see that draw says true. And the reason that we don't have any other truths in here is because we just labeled them different numbers, that's all. So new game. Game over, look, this is an or statement, and this looks at all our results from diagonal right, diagonal left, columns and rows, and draw as well, and it tells us whether the game is over or not. Going back to our game sheet and the code on our game sheet, we have a look at the different routines and functions. We've been through add counter, change user, we'll have a look at that in a moment, FTM play column, game control, and show labels. So let's go to change user, and we can see that change user, when we call it, it's a simple if statement. If we're on player 1, then change it to player 2, else we move it back to player 1. So if we're on player 1, we change it to player 2, and if we're on player 2, we change it to player 1. And we're changing the range end player. So that's the control for whose go it is next. But keeping on the sheet still, we can see that we have label 1, 2, 3, 4, 5, 6 and 7. These are almost all identical to the first one that we've been through, LBL_1. The only difference is we refer to itself, so we refer to label 1 here and label 1 here. For label 2, we refer to label 2 here and label 2 here, and likewise for each one of them. They're all identical apart from their calls. For module Connect4, we've been through FTN range from pixels, FTM range, which we're using within the Excel sheet as a function, and new game. FTM range, we haven't been through that yet. FTM range takes in a range, int value, which is the player number, it'll either be 1 or 2, and int match is a number of consecutive counters to match. The comments here are used as an Excel formula to test if a number appears a consecutive number of times. First off, we test the range to see that we have a range. And if the range count is 0, then we exit this function immediately. Next, we run through a for loop and we say each C in range. So range is a parameter and C we set as a variable. If C value equals int value, so that is if the first cell in our range equals our player number, then we're going to increment the counter. Once we've incremented the counter, then we're going to see whether the counter equals our match criteria. In this case, it will be 4. So the first time through, the counter will say 1, which doesn't match 4, so we skip over here. We loop again. Then the next time we loop, if our cell value does not equal our player number, then we jump to else and we clear the counter to 0 because we do not have a consecutive number of counters. Next iteration, if our next cell value equals our player number, then we add to the count. And each time we consecutively come to a cell with our player number, then we'll keep the counts going. And each time we keep the count going, we test against our match value. As soon as our counter equals our match value, then we return the count number and we exit the for loop. Finally, we have a check to see whether the counter is less than our match number. If it's less than our match number, then we return a 0. So the two values that are returned from this function are either a 0 that it does not match, or the number of matches that it has made that are correct. So the number of matches it has made are dependent on int match. And that's how this formula works. Finally, we might want to do some housekeeping around the look and feel of the sheet. So we'll hide grid lines, formula bar and headings. We'll ensure that the grouped area is grouped, so we keep the playing area clean. And that's the game, we just add in counters. So that's the Connect4 game. As we said, it uses conditional formatting for the game area and some of the controls to give a look and feel of the game. It uses the activeX label, and we use a custom pointer for the mouse. We use in worksheet coding, and we also use some module coding for this. The other thing we do is we have a defined user function, and we've been through that, where we can use a function that we've written in Excel's VBA, and we use it in the spreadsheet just like a normal inbuilt function of Excel. If you've liked this, please take a look at the other games that have been written and comment, like and subscribe. Thank you for your time.